In this video, we're going to learn about the side angle theorem and the triangle inequality theorem and how to use them with given examples. Let's start with the side angle theorem. This states that if you have a large angle, or the largest angle in a triangle, it will be opposite the largest side in the triangle. For example, if you have a right triangle, we've always stated that the hypotenuse is always the longest. And that is due to the fact that it's across or opposite 90, which is bigger than these two angles. So if the largest angle exists here, opposite the largest angle will be the largest side. The same goes for the smallest angle with the smallest side. So in this example here, it says name the longest and the shortest side in each triangle. So you're going to look for the largest angle, and then you're looking for the smallest angle. So for the largest angle, in this case 85 degrees, G is the largest angle. Opposite G is side EF or FE. So the largest will be EF or FE. The smallest will come if you look across from the smallest angle, which is 26. And that side length is FG. It's across from 26. FG or GF. So in this case, they actually just ask for these two side lengths. Sometimes they ask you to rank them, like order the angles in the triangle from smallest to greatest or largest, or they just ask for two side lengths. Just depends on the problem, and you will have to correctly read the directions in order to answer them correctly. This section here asks you to order the angles in each triangle from smallest to largest. Oftentimes, those students that may look or read very quickly through the directions might just see smallest to largest and write 14, 15, 20. But they're asking you to order the angles from smallest to largest. So you need to look at the side lengths and then go across. So smallest, 14. Across from 14 is angle Z. That's the smallest. Next, 15. Across from 15 is angle X. Lastly, 20, the largest. Across from 20 is angle Y. So whether you're looking for an angle or you're looking for a side length, you need to look across the triangle. Now we're going to talk about the triangle inequality theorem. This states that any two side lengths of a triangle must have a sum larger than the third side. Or if you compare just the two smallest sides, if you add them together, it needs to be bigger than the third side. So if they say state the three numbers that can be measures for the sides of a triangle, find the two smaller numbers and see if the sum is larger than the third number. And if it is, it can be a triangle. If it is equal to or less than that number, it cannot be a triangle. So in this example, 5 and 6, their sum is 11. That's bigger than 7. So this is yes, it's a triangle. Because the sum of the smaller two is bigger than the third side, 7. If we go to number 10, the problem with this one is you have, sorry, no problem. The two smaller sides we'll call 6 and 10. 6 plus 10 is equal to 16, which is larger than 10. This is also another yes. If you look at 12, 9, and 11 are your two smaller ones, sides. That's 20. This ends up being less than 23. This is going to be no or not a triangle. You might be asking yourself, what if they're equal? What if the two sides are equal? So if I have 4, 5, and 9. Okay, this is also not going to be a triangle because 4 plus 5 is equal to 9. And the statement says it's got to be greater than. And equal does not mean greater than. So this will actually be a collapsed triangle. It won't actually be a triangle that you can see. So this is a no as well. Lastly, they may ask you to find a range of possibilities for the third side of a triangle given two sides. So find the upper and lower bound for the possibilities for the third side. Well, the first situation, you're going to assume that the two smaller sides are going to be the given side. So 7 plus 12 has got to be greater than this x term, the third side. So 19 is larger than x, or we write it as x is less than 19. So my third side has to be less than 19. How much less, though, we have to figure out by thinking about the second possible situation, where 12 is actually the biggest side and 7 is one of the smaller sides. So it would be some number plus 7 has to be greater than 12. So solving for this, subtracting 12 from both sides, x has to be larger than 5. So we have two things. It's got to be bigger than 5, and it's got to be less than 19. If you find any number within that range, you have a triangle. You cannot choose 5 or 19, though, because those aren't included in the inequality. 5 is not greater than itself, and 19 is not less than itself. But any number in between will make a triangle. The other way you could write it is as a compound inequality, 5 less than x less than 19. So if you're finding out the range of possible answers for the third side, you first assume that the two sides given are the two smaller sides, because their sum has to be bigger than the third side. The second situation is you assume that the 12 is the biggest side, and 7 and some missing number is the smaller side, and you solve that inequality as well. And that gives you your two bounds between 5 and 19. All right, just to recap, we have side angle, which states that the bigger the side length across from it, the bigger the angle, and vice versa. And then we have the triangle inequality theorem that states that any two side lengths, when you add them together, must have a sum larger than the third side.